the topic that our team chose was splay trees. What are splay trees? Splay trees are self-balanced binary trees. What makes splay trees different than binary trees? Splay trees have one additional operation that is called splaying. So what is splaying? Splaying is bringing the frequently accessed elements on the root node. So why are we doing that? We are doing that to make operations faster. In the cases where we need our elements, where the elements are frequently accessed. There is one more advantage of using splay trees over any other self-balanced binary trees. That is, its amortized time complexity is log n. So what are the applications of splay trees? One of the application of splay trees is cache implementation. So now we will understand the concept of deletion in splay tree. There are two kinds of deletion performed in splay tree, which is top-down splaying and bottom-up splaying. So what is bottom-up splaying? In bottom-up splaying, we first perform the normal deletion, which is done in binary tree, and then we perform splaying. And in top-down splaying, we first perform the splaying action and then we delete the node. So let's explain the bottom-up splaying through an example. So we are given the binary tree and we need to delete node 12 from it. So we simply delete the node because it is a leaf node, so we remove the node. So after removing the 12th node, the structure of our binary tree looks like this. So now we need to perform splaying on node 10 and we need to bring it to the root node. So we have to perform some rotations to make it to the root node. So we perform left rotation on node 7 and then afterwards our structure will look like this. 10 will be now the parent of 7. And what do we do now? So we need to perform a right rotation on node 13. So after we have performed right rotation on node 13, our structure will look like this. But still, node 10 is not the root node. So now we need to perform a rotation again. We will perform right rotation on the current root node, which is 14, and our final structure will look like this. And now we can see that node 10 has now been the root node and deletion is done using bottom-up approach. Earlier we have seen bottom-up splaying. Now we will see top-down splaying. In top-down splaying, we first splay the tree and then we perform the delete operation, and finally we get two subtrees and we perform a joint operation. So let's understand it through an example. So we have this binary tree and we need to delete node 14 from this tree. So first we will perform splaying on node 14 and we do a left rotation on node 14 to make it a root node. So after performing a left rotation on node 14, we get a binary tree like this. Now we can see that 14 has become the root node. Now what we will do is we will delete the root 14, and after deleting we get two subtrees, that is 9, 7 and 12 and 15. And we need to perform again a joint operation. We need to combine these two subtrees to make a tree. So first we need to perform splaying again on this subtree to add the node 15. So after performing a left rotation on node 14, node 9, we get a tree like this. And now we can simply add the 15 node in our tree, and after inserting node 15, we get our final tree like this.
Hello, as my friend Narendra told about Splay, now I will tell you about what is there in Splay. So basically, we have 6 kind of operation in Splay. These are just rotations. So first is jig rotation. We call it as a right rotation also. Here what we have to do is, suppose 4 is our node and if we want to make it or we want to splay. So splay means we have to make it root. So we have to make 4 as a root node. So we have to rotate. We have to rotate in right. So that 4 come at the place of 6 and 6 go down and the structure will look like this. So if I do 4 come here as became my root node, then 4 have 2 children. 4 have 2 children. So when 4 will be root, one of his children cannot be directly his children. So some other things has to be happen. So what we do, the root node of our here will be have the second children of 4. So this is jig rotation. Now there is a second rotation, jag, which means left rotation. Here we have to space 6, means we have to make 6 as a root node. So for making 6 as a root node, we have to do left rotation. So making 6 as a root, so we have to carry this thing there. So 6 become root, then 4 will go down, 4 is here, 3 is a normal, 7 is right here. Now only point is 5 where will go. So jag operation. So here we have to do left rotation. Suppose we have to space 6, means we have to make 6 as a root node. So for that, what we will do? Making 6 as a root node, we have done. Now 4 will go down, 4 has become left children as it is BST, and then 4 has one children, that is 3, that is here, and 6 has the right children as 7. So now I will explain about two last rotations, zigzag. So suppose I have to Splay 5 and 5 has direct current, I cannot directly make it as a root node. So first I have to do jig operation, left rotation on my node 5, sorry, on node 4. I will, if I do jig operation on 4, then my tree will look like this. Now I will do jag operation on 6. So if I do jag operation, 6 will come down, 5 will be my root node, and that is what I wanted. So this is jig operation. And now jig. So suppose same here I have to Splay 5. First of all, I have to do jag operation on 6. So after doing jag operation on 6, my tree will be like this. And now I will do jig operation on 4. So again that same tree will be. That's all.
Hello, my name is Shadab and I am here to discuss the instruction part in the Splay trees. So here we are. So how we start the making a tree? We will take first a node and it will be the root node itself. So here we have taken 17 as the root node, and after 3 steps I am explaining how insertion works in the Splay trees. So here we are. Like I have this tree, this is Q tree, and I have to insert 7 in this tree. So I will check where it will lie, because it is based on binary search tree. So we have to keep the maintenance binary search tree order. So 7 will first come to root node, and it will be less than this, then it will come to left, then again it will be left, then again it will be left. So then we have inserted. Now in this, what is the meaning of insertion in Splay tree? We have to display the tree after insertion, display the node, that node. So here we do displaying. What we will do? We will check the grandparent of this node, and after we will see that the direction is same. So we will do the zig rotation. We will do zig rotation on the parent of the node, and after that we will maintain the order of BST. Like this will zig rotation will take place, and the 10 will become the root node, and 10 and 15 will be the right child, and 7 will be the left child of this node. So we will check the whether 7 has come to the root node. No. So we will again do the zig rotation. We will first check where its grandparent. It is in the same direction. So we will do one zig rotation again. We will do zig rotation again. Then this one will come. 7 will go up, and 7 will be the left child, and the other will be the right child's. This whole tree comes down, and this one will form. So at last, now we will check the whether 7 has come to the root node. No. Then again we will do zig rotation, and 7 will come here, and 17 will go in the right child, and 10 in the left child, and 10 will be the right child of the tree. So this is how insertion works. And if we had a Z rotation, then we will also do in the similar manner and form a insertion. Thank you.